All right, bell ringer coming up. There you go. Describe what photoreceptors are. Detail the significance of rods and cones. When you're finished with this, please submit your bell ringers. Turn those in so I can give you credit for them. Those of you in here, I'll just come around and check them then at the end of class. Does that sound good? All right. All right, give you some time. Give you one more minute to finish up here. Just working on the bell ringer right now, Megan.
Okay.
All right, let's go over this. So photoreceptors, what are they? What are photoreceptors? TC, go ahead, man. Yeah. Awesome. Yep. Good job. So photoreceptors, where are they located mostly though in the eye? I know you said the eye, but where in particular in the eye? Do you remember? No? Anybody want to help them out? What's that? Okay, the rods and cones are part of photoreceptors, yep. But where are they located, these photoreceptors in the eye? Where are they located? It's the inner layer, which we'll talk about today, a little bit more in detail. Rebecca, you know? The retina. Yep, good job, the retina. So when you think of the retina is like the back screen in the eye. Okay, it's the inner layer, and these are that's where these photoreceptors are located. And with rods and cones, right? So what are cones? What are they more receptive to? What is their significance, I guess you could say, as a photoreceptor? Zerby?
Cones are capable of, are responsible for that's not cones. It's a high light.
Yeah.
Levels.
Yeah, good job. So cones, when you think of cones, think of color. Okay. So they're more receptive to color and brighter light. Okay. So brighter light. And when you think of color, that's kind of what that will depict or receive. All right. And then rods obviously are. Yeah. So dimmer light, and then it's more like spatial, okay, different types of figures, right? And with rods, I gave that example earlier, in the video on Wednesday, I believe it was, when you are in a dark room for a long period of time. It's almost like you can see the shapes, you can see the figures in, let's say, that dark room. Like you can see the nightstand, or you can see another chair, or something like that. Even though there's very dim light in that room, you can still perceive those objects in the room. Does that make sense? I'm sure that happens a lot to you guys. And then if you're in that dark room for a long period of time, your cones are almost like shut down. They're shut off for that time being. And when the light turns on, it's almost like a shock to you. It's like, oh, it's too much. It's too bright. Okay, the rods are too focused on it at the moment. And whenever that happens, your rods and your cones act in a certain way to receive that information to send that signal to your optic nerve, which I think is pretty interesting. All right, good. All right, is there any questions on that? You good with that bell ringer? Again, those of you at home, please turn those in. They're due tonight at midnight, so make sure you turn those in. There's 4 of them that I need you to know. All right, real quick, let's go over this diagram from yesterday so we can pick apart the eye, the anatomy of it, and I'll give you a grade for that then at the end of class. So real quick, A, what's A? What is A? Megan, what do you got? The optic nerve. Good job, the optic nerve. And right here, guys, okay, so obviously we know this as the retina, which we'll talk about here soon. But right here is where that nerve enters the eye. And these photoreceptors are receiving this information and sending it as like a impulse or like energy towards the optic nerve. They call this the optic disc, okay? And once that information is sent there, that signal, it sends it to the brain, and where it could be processed, where at in the brain? What lobe? Occipital. Good job. Good work. Okay. But take notice, is there any photoreceptors, or is the retina stretched out over this area? No, it isn't. Okay, and they call that the blind spot. So you remember that activity I had you doing? You stare at the circle, the dot in the circle, and after some time, that other circle will disappear. Okay, and that's what happens when that light is projected onto your blind spot, just because there's no photoreceptors there. There's no way of processing that information, understanding what you're visualizing. Does that make sense? Okay, so that's the optic nerve. That sends that information as an impulse, this neural connection to your occipital lobe. All right, B. What about B? What do you have for B? Rebecca? We'll just work our way around.
Muscles.
Okay, yeah, muscles. So it's like the iris, right? Okay, the iris. So the iris is it's more effective when you have diminishing bright light. Okay, so like say it's really bright, your pupil, okay, obviously will extend or contract, and your iris is in control of that. And with the iris, it has a color pigment, right? So that's when you have green, blue, black, brown, whatever eyes. Okay, and with the iris, obviously if it's brighter, it's a brighter light. Okay, your iris might affect your pupil to shrink or expand depending on how bright or how dim that light is. And with concussions, right, TC, that's a great way to detect if you're receiving that information to your brain, that concussion. All right, good. All right, C. Okay, this is almost like it's almost like a shield, right, of the eye. What is that? TC? The cornea. Yep, good job. The cornea. Good. All right, D. Sarah? The pupil. Good work. That's where the light enters through. Okay, obviously the cornea, the light enters through the cornea, through the pupil, depending on how bright or dim the light is. The iris will obviously expand or contract, and the light comes through the pupil to this E. Zerby? The lens. Good job. And the lens projects that image on the back of the eye, mostly located where this area is. And F is what? Back over, Megan. Nope. Right here, right here. It's part of the retina where the most photoreceptors are located, cones especially. Starts with an F.
I'm not sure.
Rebecca, you want to help her out?
I have blind spot.
Oh, you have a blind spot? Oh, the blind spot's right up here where that optic nerve is. So that's the fovea, okay? So fill that out, guys, if you don't have that, the fovea. So that light comes through, okay, hits the lens, and the lens projects that on the back of the retina with the inner layer of the eye, and that's the fovea, F-O-V-E-A. That's where most of the photoreceptors are located, obviously, because that's where most of the light in your visualization is focused on, okay? And then G, the fovea is a part of what? The inner layer is the, go ahead, Zerby.
Right.
The retina. Good work. There you go. There you have it. So make sure you guys know that. I'll probably be on the quiz or test. Hey, Gracie. Just went over the bell ringer and the eye here. So I'll put that up for you then towards the end of class. All right, there you have it. There you have it. All right, so let's go over the anatomy of the eye. I guess I forgot to go over that, didn't I? I think I talked over photoreceptors Wednesday, and I just put this out for you Thursday since we're remote. And I'll go over this now for you. Sorry about that. But hey, you have it now, and when we review it and when we go over it, you should know it pretty well. Okay, slideshow. So let me go over this real quick, and then I have a short video for you. That's it. All right, so when we talk about the eye, the main things I want you to know right here. So let me move this over so you can see that. So when you're looking at the eye, the outer layer that looks white. So when you're looking at your eye, it's the white part of your eye. That's called the sclera. Okay. So outer layer, I'll just put a 1 here. Outer layer is the sclera. S-C-L-E-R-A. Okay, sclera. And mostly its job is where the muscles are attached. Okay, the muscles are attached to the sclera, which allows for eye movement. Okay, so that outer layer, mostly its job, okay, is for the muscles to attach to it and allows for eye movement. Okay, and that's the sclera. Sometimes, which we're going to talk about, the middle layer of the eye, when you're fatigued, or let's say you have some sort of lack of oxygen or blood flow to your head or your brain. Okay, sometimes that middle layer will be present through your sclera. Okay, so that like whenever you have blood vessels showing in your sclera, that happens a lot. That happens often. Sometimes your choroid will appear through the sclera, which is interesting. Or if you just get punched in the eye or something like that, it'll rupture blood vessels, which you can see presently through the sclera. Which moves to the next one. The middle layer, I guess you could call it, is the choroid. C-H-O-R-O-I-D. And that's where the blood vessels are located within the eye. So the outer layer, sclera, muscles are attached to it, allows for eye movement. And then the middle layer is the choroid, which is blood vessels. Okay, the blood vessels are located there, like I mentioned before, sometimes with fatigue, especially when you're 21, you drink too much, you have lack of oxygen going to your head a little bit, so your blood vessels might appear through your sclera. And so that happens a lot. There's many other examples that I could use for that. Or if you just have any type of impact to your face or your eye especially, you might see the choroid present through your sclera. And then finally, the inner layer, we already talked about the retina. The retina. And especially in the back of the eye, that's where you'll see the retina mostly. Photoreceptors are located there. Okay, so those photoreceptors, like cones, rods, are located in the retina, which allows us to perceive different types, with vision. Okay, it sends that signal, that impulse to our optic nerve, which can be processed in the occipital lobe of the brain. All right. So again, the sclera, outer layer, white, muscles attached to it, choroid, middle layer with the blood vessels, and then the inner layer, okay, is the retina, where photoreceptors are located. All right. So real quick, how does the eye work? All right, so like I mentioned before, we have the cornea, all right, and that allows any type of light to come through, which will be projected to the pupil, and then the iris, depending on how bright or dim that light is. It might contract, it might expand to allow us to visualize whatever we're seeing. Okay, if it's a very bright light, sometimes it makes our eyes jump, okay, obviously, and it allows more light to enter through. And in shocking or exciting images, whatever it might be, it makes it more present and prevalent of what we're seeing, that we can see the whole picture a little bit more. And if we're not focused on anything, our pupil or iris kind of diminishes a little bit depending on how bright that light is. So that light shines through the cornea into the pupil iris, depending on how bright or dim that light is, contracts or expands. And that light hits the lens, which is right behind the pupil. Okay, and that lens is almost like a projector. Right? That projects the light on the back of the eye where the retina is located, right? So the retina is that inner layer, okay, where the photoreceptors are located. And more in particular, the fovea, which is a part of the retina. Make sure you know that. That fovea contains more cones than anything. All right. This is where abundance of cones are located in the retina, which allows us to see different types of colors. Okay, especially color, obviously, and it is more, I guess you could say, sensitive to brighter images. Okay. And once that fovea is receiving that image, that light, okay, it sends information through an impulse. Okay, it sends it like a electrical impulse, right, to our ganglion cells, which allows us to understand that a little bit more. And it's more of a direct message, which it travels down the retina. Okay, travels down the retina, that image, I guess you'd say, that electrical impulse to the optic nerve. And that optic disc, like I mentioned, has no cones. It has no photoreceptors there. So if light would ever shine onto that optic nerve or that optic disc, as they call it, you won't be able to see anything. It's like a blind spot. It's like when you're driving down the road, that blind spot on your car. You can't visualize it. You can't see it through your mirror. Okay, the only way you can see it is if you actually turn your head to the side. It's very similar. Okay. But real quick, again, how vision works. The light shines through the cornea, through the pupil, the iris, depending on how dim or bright that light is, will adjust. And then the lens is almost like a projector, and it projects that image, okay, to the retina. And then the retina, mostly where the fovea is located, okay, it's mostly directed towards the fovea, where their photoreceptors are located. That is going to send an image to ganglion cells. That ganglion cell is going to send that information like a energy, an impulse, to the optic nerve, and then that optic nerve is going to send that information to the occipital lobe of the brain, where we can process it, we can understand it. All right, and like I mentioned before, we're going to talk about this more next week, is when that image is being projected on the occipital lobe, it's actually upside down. So as we're visualizing this, we actually see it upside down, okay? And our brain has the ability to process it in a fast, alarming rate of how we visualize and see things to make it right side up, obviously, okay? Which I think is pretty interesting. So our brain's actually, our occipital lobe, is processing that information that's actually wrong, that our vision, that our eyes presenting to our occipital lobe. It flips it right side up so we can actually see, grab, and touch things and react to certain objects or stimulus, which is pretty cool. All right, and like I mentioned before with transduction, that information is sending it to the optic nerve, where we can process it and visualize it. And this is a little bit more where the fovea is located, that optic nerve. Okay, well, these are the rods and cones. It's grabbing that information and sending that impulse to the optic nerve, where we can process that information to the occipital lobe. All right, so number one, light entering the eye triggers photochemical reactions in rods and cones, the back of the retina. 2, chemical reaction activates bipolar cells, which are pretty much right in the middle. They're the middleman. And then 3, bipolar cells activate the ganglion cells, which is really the last line, that the ganglion cell sends that information to the optic nerve. And that optic nerve transmits that information, okay, that impulse, to the occipital lobe for us to understand what we're seeing. It's like that barcode scanner, right? You know, I used that example earlier. It's sending that information where we can process it, we can understand it, and we can perceive what we're visualizing. And that's called what? What is that term called? Geez, I'm going nuts over here. What's that term called? Starts with a T. All I got to do is answer this and we're done. Go ahead. Transduction. You got transduction. All right, and we went over this already with the retina, where the rods and cones are located, and fovea, right? Okay, and then the fovea right here is more a centralized location where these photoreceptors are located, part of the retina. And we went over this already, and then you have that activity to help you, guide you to understand that a little bit more in detail. All right, is there any questions on that, guys? We good? So if you had any incorrections on that graphic organizer, you fixed it. All right, good, because that will probably be on a quiz or a test in the upcoming future. All right, that's all I got. I'll show you a video real quick explaining it, reviewing it, and that's it for today. There we go.